Welcome to math. Today's sheet is called Expectations for Compound Events. We're trying to make things a little trickier here and adding maybe more than one event and trying to figure out what our outcomes will be when we have more than one event and what the probabilities would be of getting a specific outcome. And to do this, I'm going to demonstrate what's called a tree model. And it's called a tree model because we have different branches that we are going to kind of show as arrows. So let's take a look at the first question. It says, find all the expected outcomes of flipping 2 dimes and draw the missing arrow and fill in the blanks. So if I flip 2 coins, what are all the possibilities? Well, the first coin is either going to be heads or tails. And then the second coin is either going to be heads or tails. And that's going to give us 4 different combinations. We could have a first coin be heads and the second coin be heads. We could have the first coin be heads and the second coin be tails. We could have the first coin be tails and the second coin be heads. And we could have both coins be tails. So we've got 4 different outcomes from those 2 flips. How many ways are there of getting the result? So how many ways are there of getting 2 heads? Well, just 1. 2 tails? Just 1. 1 head and 1 tail? Oh, well, there's 2 ways of getting that. And that's what it's asking you to do. And we're going to kind of continue this line of thinking as we look at some other probability experiments. So Randy and Tom play a game in which they take turns spinning a spinner twice and adding the results. The spinner is divided into 2 equal parts labeled 1 and 2. So draw the missing arrows and write the addition statements in the table. So let's see. If your first spin was 1, your second spin could also be 1, but your second spin could be 2. We're going to draw these missing arrows. And the outcome of the sums is going to be 1 plus 2, which is going to equal 3. I need you to fill out the bottom part of this chart. So let's say your first spin was a 2, while your second spin could be a 1 or it could be a 2. And you can write your answers down. And answer the following questions. How many ways are there of getting these results? A result of 2, 3, or 4. And then it's going to ask you what fraction of the time will they get these results. So when we're talking about a fraction, the top number will be how many times you'll get the result, and the bottom number will be how many possible outcomes there are. So if we just want to kind of scroll back and take a look here at getting maybe the answer 2, well, I can already see by the way the graphic organizer is set up that there are 4 different outcomes, and only one of those outcomes is going to give me 1 plus 1. I need both my spinners to land on 1, so 1 out of 4 would be the fraction. I'll let you finish it off. Here it says if Randy and Tom take 40 turns total, how many of each result of 2, 3, and 4 can they expect? So you're making a prediction based on the probability, based on the fractions even. Number 3, find all the possible outcomes of flipping 3 dimes and draw the missing arrows. So the outcome of your first dime could be heads. The outcome of your second dime could be heads. The outcome of your third dime could be heads, but the outcome of your first dime could also be tails. And then the outcome of your second dime, the possible outcomes are going to be heads or tails. And your third dime, right, just like above, your outcomes could be heads, tails, heads, tails. And I don't mean you're going to flip that third dime 4 times. I just mean these are the outcomes. Your outcomes could either be heads or tails, but if we're looking at all the possible specific outcomes, you could have a first flip of heads, a second flip of heads, and a third flip of heads, which would give you this outcome here of heads, heads, heads. If you had a first flip of heads, a second flip of heads, and a third flip of tails, that gives you a different outcome. Okay, so fill in this chart and try to figure it out. Here it says how many ways are there of getting this result. So how many different ways are there of getting 3 heads? There's only one. I'll let you answer these questions. They're similar to the ones before, but they're just going to ask more questions. So they do end up asking which results are equally likely to occur. Use your answers to part B to answer the question. So looking at 3 heads, 2 heads and 1 tail, 2 tails and 1 head, and 3 tails. Which of those answers have an equal odds of happening? And it'll be based on your results here. Which outcomes of the 3 flips are most likely? What fraction of the time will you get the following results? And how many of each result do you expect if you do the number of sets of 3 flips? So you might need to use the sides of your page or make a little chart to set this up. But I want to see how you do with question F here. Number 4 makes you do a little visualizing on your own. I suggest drawing a model. 2 spinners are divided into 3 equal parts labeled 1, 2, and 3. Make a chart to show all the expected outcomes of spinning twice and adding the results. It should have 3 column headings: outcome of first spin, outcome of second spin, and outcome of the sums. How many ways are there of getting each outcome, and what fraction of the time can you expect to get each outcome?